I'll just keep talking, so if I see it, just cut it, so I'll come back, so no problem. Because I can't concentrate both. So, good afternoon. I just want to give just a couple of lines regarding L&T, what we do in water and wastewater. I think all of you must know L&T. If you don't know L&T, you are not Indian. You came from somewhere else. So I assume that all you are Indian, so you know L&T. But in the water sector, L&T has started about less than a decade from ground zero. And today we are about $2 billion in the water and wastewater industry alone in L&T. And we have got plants all over India. I think using some of the C-Tech technologies, we have done significant amount of projects here. And we also did projects in the Middle East, Africa, and we are growing and growing and growing. So that's L&T in the water sector. The subject I want to discuss today, I'm not seeing that. What's happening here? Where is the presentation? Stopwatch. You have to stop. Good. Okay. So we all heard about wastewater reuse. We heard about the necessity, the water stress in India, so on and so forth. And coming from Chennai, some of my colleagues actually called me from overseas and they said, you guys, you do water and wastewater, but you don't have water in Chennai, so how do you survive? I think that probably will be addressed soon in Tamil Nadu in general by building more desalination plants and so on and so forth. The water reuse is very important to reduce the water stress in general, and also to utilize and manage well the water resources in the country in general. So the subject I'm going to talk about will be very specific for water reuse. I will be talking about membrane bioreactors, which is one of the technologies used for wastewater reuse. This statement is my favorite statement. It says more like, don't judge water by its history, you have to judge by its present. So it says here, no higher quality water should be used for a purpose that can tolerate a lower grade. That's UN Council in 1958. And it also says water should not be judged by its history, but its quality. When we talk about water reuse, we always remember about Singapore, and also a country in Africa is called Namibia. I don't know, most of you haven't heard of. They totally use sewage for drinking water. Totally use. They don't have water resources. So membrane bioreactors is, I call it the mother of all wastewater reuse. And that's what I'm going to talk about. I will skip some of this. So the membrane bioreactors, they give a less footprint, less piping, reuse quality, and high quality waste. There's not only a single process flow sheet that would give you a wastewater reuse. There are many venues. And like Sandeep just mentioned earlier, it depends on how deep your pocket is. Membrane bioreactor you must have a deep pocket, little bit deep pocket, in order to use it, because it's a little bit more expensive. But it has got a lot of benefits. And some of the benefits is that you have got a smaller footprint, you get a good quality treated water. And those of you who are familiar with sewage treatment plants, you have got primary clarifier, you have got secondary clarifier, you have got biological reactor. If you want to reuse the water, you have to have a tertiary filtration and so on and so forth. But MBR combines all of that, and you will get a very small footprint biological reactor followed by membrane filtration system. And that's all you need. And you'll get a crystal clear water. And if you see a water that came out, treated water that came out from a MBR plant, you'll be tempted to drink it because it's so clean. Again, it's a combination of secondary and tertiary, and there are two schools of thought in terms of doing that. One is submerged, the other one is outside the tank. Hollow fiber flat sheet, We've got smaller footprint for it's a better quality than ASP and SBR alone. But with SBR, if you put a tertiary, then the quality will be also the same. If you put a UF after SBR, you will also get the same quality. And fibercast MBR, I think, is the latest arrival of membranes, which is a combination of hollow fiber and flat sheet. Now, these are some of the design parameters. I don't want to confuse you with that. And the main reason that the tank is very small is simply because the MLSS is very high. We use up to 8,000 milligram per liter MLSS. And the quality of the water that comes out is, if you look at this, you see BOD is 5, NTU 0.2 turbidity, and total nitrogen 10. Total suspended solids is undetectable. You can't detect the total suspended solids coming out from ultrafiltration membranes, which has a pore openings of 0.04. And these are some of the examples of what quality you're going to get from activated sludge process versus MBR. How am I doing with time? Okay, good. So the other thing also, when people hear about MBR, they always think about small scale. I think that perception also existed with the SBR at the beginning. When the SBR also started, people also thought that it has to be a small plant. When you talk about big plant, people used to say, no, big plant is not possible. And now you've got the larger scale SBR plants and also larger scale MBR plants. So if you look at this plant in China, 600 MLD, that's huge. That's a huge big plant using MBR. And it's used a membrane area of 1,728,000 square meter of membrane surface area. That's significant. Now, LNT, what we have done is we do projects in the Middle East, and those projects we do in the Middle East is all for reuse. In the Middle East, there's no water. You can't just build a plant and waste the water into the ocean, or there's no river actually. You cannot send it to the rivers. So what we normally do is 100% reuse. So one of the plants that we have done is called Doha sewage treatment plant, where we have used a sequencing bioreactor SBR, similar to C-Tech technology, and the effluent from that we put through an ultrafiltration system, and the quality of the water that came out is extremely good. It's used for reuse in Doha. And if you go to the Middle East, all the greenery that you see in the Middle East is not from a seawater desalination plants. It's mostly from where? It's from sewage treated. And people accepted that. And I hope that India also will accept that soon. Now this is some of the pictures of that. So what makes the MBR technology going forward? The price is going down. The price of the MBR is coming down significantly. Simply because I think the Chinese are making a lot of it. And that competition actually putting a lot of stress on the vendors, so the price is coming down, the quality is getting better, the reliability of the MBR is also getting is improving, and a lot of vendors are available as well. So I just want to conclude that when it comes to wastewater reuse, India is not in the forefront. But what I noticed recently is that the industrial complex in India, actually they reuse the water. Recently I've been in Tripur in Tamil Nadu, and I found one of the treatment plants that I visited, ETP, that they are using everything that comes out from the plant. So what they do is they have got a centralized wastewater treatment plant using a biological reactor followed by UF and then followed by RO, and then they take all the treated water back to the industry that sent to them. And the industries collect money and put back into the treatment plant. That's what's happening right now in India. I hope I made on time. Thank you very much for your attention.